Hey guys, so today we are taking notes on linear correlation. So we're starting our 5th unit, and we just ended our last one and we just took our test. So just going to start this video off with our table of contents in case some of you guys are missing any of your notes. At this point, today's notes should be page 55 and 56. So that's going to be linear correlations and then correlation coefficients as well. The last notes that you guys got before the test was on our arithmetic sequences, recursive, and explicit forms. And then this will go right behind them. So if you need to pause this screen for a moment so that you can make sure that your table of contents is up to date and make sure you have everything that you need, you can. Otherwise, I'm going to continue moving on, and you can pause at any time if you need to. So let's go to that page and look at our first set of notes for today. So these are attached to the Google assignment. When you cut them out, you need to cut out 4 squares. So the first square you'll cut out will just be from the first page, the linear correlation, the top part of it. The second part of that first page will be its own square. So the positive correlation part, which is the second part of that first page, will go underneath it. So page 1 is actually 2 pieces, 1, 2, and then the second page as well is 2 pieces. So this is the top part of the second page. This is the second part of the bottom part of the second page. And you can cut them right above the type of correlation that they have. So right above that box is where you'll cut on each page. And that way you'll have your notes creating some sort of a flip chart for you, and you can get it all on one notebook paper. So in the end, you should have 1, 2, 3 moving flaps, and then that back one is just glued directly to your notebook page. So if you need to take a moment to pause this video and get those cut out properly, feel free. This is the title of this page. I'm going to go over real quick what I want you to write, and there's very minimal writing on these because most of it is printed. So linear correlation, as we move into this, linear correlations are a scatter plot that helps us determine if there's a relationship between 2 sets of data. So right here in the first blank, I want you to write scatter plot. Okay, so it says a scatter plot is used to determine whether a relationship exists between 2 sets of data. So we have an example here, and that's exactly what this paragraph says. The scatter plot at the left displays the relationship between the number of baskets scored, so it tells you right here, baskets made in the homecoming game, and pairs of blue socks owned by the players. Pairs of blue socks owned by the players. So one of the pieces of information goes on the x-axis, and the other goes on the y-axis. And then it appears that there is some sort of correlation between these points. So the linear regression equation was found to predict the pattern that was seen in this graph. So the slope of the line is positives. As the number of pair of blue socks increases, the baskets also increase. So we can see in this example that there is a correlation between the number of baskets they're making and the number of socks that they have. I apologize for that. The lights are timed here in the building. So the definition of correlation is the measure of the strength of a linear association between 2 quantitative variables. So how correlated are they, or how strongly are they related? And look here, it says that it's between 2 quantitative numbers, meaning that it has to be measured by numbers. Qualitative is something different. That's looking at the quality of something. So if I had a bunch of drinks and I wanted to know if the drinks were hot or cold, that would be different. Okay, and that wouldn't be using numbers. It's, they're really hot or they're really cold drinks. We're looking at data that has numbers to help us measure it. So the number of socks and the number of baskets. So I want you to flip that open, and the first tab that we're going to look at is positive correlation. There's different types of correlation that we can have. So positive correlation, it says, indicates the extent to which, write really little here, data increases at the same time. So in that first blank, you're going to write data increases at the same time. The y values will increase as the x values increase. So the y values will increase and the x values will increase. So they're going to be moving the same way at the same time. If you look at this first example that we have here, all these dots, if I were to draw a line going through them, they're all really closely correlated and related, right? So these data points can be described as clustering about a rising straight line with a positive slope. And we know that if anything goes up, that's a positive slope, right? We read graphs from left to right. So this is a positive slope and it's a positive correlation. Well, same thing over here, even though it's different. So it's still a positive slope, still going up. However, what we're noticing is that some of these points on the scatter plot are further away from the center than others. So that would be a low positive correlation or a very weak correlation because they're not as close together. They're not as strongly related to each other as these are. These are very close to that center line. So for this first tab, I want you to write positive correlation. So that way, when this is folded down, we can see our first tab is talking about positive correlation. And then flip past that, and we're going to move on to negative correlations. So negative correlations are obviously the opposite of what we just talked about. And that is where, as you can see with these dots, they're going to be moving down. When we read graphs left to right, this is going downhill, right? So in our blank, we're going to write a negative correlation indicates the extent to which one data value increases while other decreases. And again, write really small because these are small blanks. So a negative correlation is when one data value is going to increase while the other one is decreasing. So if we look, let me draw my line here. So there's a straight line going through all these data points. But if we were to look at this data point, that has a very, very high y value, but a very low x value, right? So its y value is, up there between 5 and 6, and its x value is down there near 1. So it's high at y and low at 1. But then if we look down here, this one has a high x value, but it has a very low y value. So when one is increasing, the other is decreasing, and vice versa. And so that's going to give us this negative slope. And we can see it as well on the other side, although it's a little bit harder to even see. It almost looks like there's not really any relationship here at all. But if we were to draw a line going through these points, we can see that they're all moving down with a few outliers. But they're not that strongly related, right? Some of them are hanging out way over here, others are over there. They're not tied together as closely. So that would be a low negative correlation or a weak negative correlation. Whereas this would be a high or a very strong negative correlation. Both are going negatively, but some are closer than the others. So when you close all these tabs again, the second tab we're going to write negative correlation. So we have positive, negative, and then our last one we're going to look at, which is there's no linear correlation at all for this last one. So this one would be if there is no relationship between x and y, then the data is said to have no correlation. So you would essentially think of these x and y values as being independent, or they don't rely on each other. They're not dependent on the other one. I cannot, looking at these points, figure out if they have a positive correlation or a negative correlation or which way I should draw a line. I can't tell because it doesn't look like anything that's happening down here is affecting, a number on this axis. As this number gets bigger, I don't see this one getting bigger, or the other way around. I don't really see anything. It just looks like dots everywhere. So there's no way of knowing. These, although it is in a straight line, I don't want you to think that that means that there's correlation. It says, be careful here. While a straight line passes through these points, the line is horizontal with a slope of 0, no change. This indicates the value of x has no influence in changing the value of y. So I know when we look at this, we see a straight line, so we're thinking, well, that's really, really strong. They're all sitting on that line. But here's the difference. No matter if my x is a low number or a high number, my y value is still 4 at every single point. If I go over 1, I go up 4. If I go over 6, I still go up 4. So no matter what I change this x value to, the y value is 4 every time. So it's not changing it. So there's no relationship between the two. So for this last tab at the bottom, we're going to write no correlation. And that's all I want you guys to write for this page of notes. Once you've got it in the right order and you know how to set up your tabs, we have no correlation, negative correlation, positive correlation, and our title page on what correlations are. And that should be page 55 of your notes. So once you've got that down, and again, if you need to rewind or go back or pause, feel free to. Flip over to the next page, and we're going to look at correlation coefficients. And so this page gets glued in sideways because it is a little bit wider than it is long, so we just turned it sideways. So let's take a look at correlation coefficients. So we've talked about the different types of correlation you can have, positive or negative or no correlation. And now we're going to look at what a correlation coefficient is. So again, there's not much writing to do on this page because a lot of it is printed for you. But I do want you to have some examples to look back at in your notebook. So what is a correlation coefficient? Well, it tells us up here, a correlation coefficient is going to be labeled with the letter R. So when you use Desmos in a few days to find correlation coefficients, it's going to be labeled R. And it's a number between -1 and 1, and it measures how well a line fits the data points. So just like we saw, there's a lot of data points. If you were to put a line in the middle of those data points, how well does that line fit all the points that you're seeing? So the range can be between -1 and 1 for your R value. It can be greater than -1, but it's got to be less than 1. So it's going to be in between those two numbers. So if you were looking on a number line, it would be between 1 and -1. And it tells us right here, this is super important, a value of R close to 1 indicates a strong positive correlation, and a value close to -1 is a strong negative correlation. Okay? So -1, that's a strong negative correlation if it gets closer to -1. +1 is a strong positive correlation. And then if it's in the middle here at 0, there's no correlation. That means they couldn't find any type of relationship between the two data points. So we're going to look at the next few examples and take a look and see what we find. So this first one says, what does data with a correlation coefficient of R equals 1 look like? So if our R value is 1, we just saw up here what that tells us. A value of R close to 1 is strong positive correlation. But if it's exactly 1, then as you can see, these points are literally sitting right on the line. And I'm going over them with this blue so that you guys can see this in the video. But when you print your notes out, you'll be able to see them. That means that as this X value increases, the Y value is also increasing at the exact same rate. So they all have the exact same change happening to them. So they're very correlated. This X value and this Y value are very correlated. So this is what a positive correlation looks like. And then we have some examples right here of still positive correlations, but weaker. Okay, so this is what a correlation of maybe 0.86 would look like. So we have data points that are very close to the line, but they're not all on the line. And so again, I'm going over them so you can see them a little bit better. So this would be a strong positive correlation. They're all very close to our line, and from left to right, this is moving up. So this is a positive correlation. But if we look at a correlation coefficient of 0.46, we have some points that are really far out, but we also have a lot of points that are close. They're just not all close. So when I'm looking at these points, I can see that it is moving up as I go from left to right. It is moving up, but they're not all strongly related. So that would be a coefficient of 0.46. And you guys wouldn't have to figure this out in your head. You would plot these points. So you would enter all these points into Desmos, and when it's graphed, you would ask Desmos to find the line of best fit, and it would tell you what the coefficient value is. And from that value, you should be able to say, that's really strong positive, or really strong negative, or not really anything at all. So this would be a weak positive correlation. And again, when you're looking at these numbers, even though they're decimals, these are positive numbers. I do not see negative signs. So that tells me that it's a positive correlation. And then over here, it says, what does a correlation coefficient of R equals 0 look like? It looks like this. So again, I'm going to go over these points so you can see them better. But there's basically points everywhere, meaning I can't really tell that they're all moving in a certain way. They just look random. So that's none. And then negative. Negative. So what does a correlation coefficient of R equals -1 look like? That means that is a super strong negative. They're all on the line, just like this example. However, from left to right, this line is going down, so that's negative. And then here's two more examples of negative coefficients. So -0.92 and -0.47. So this -0.92, as you can see, these points are not all on the line, but they are very, very close to the line. And then for -0.47, we can see that as we go to the right side, these dots are kind of going down, but they're not really strongly related. They're not really close to that line. So that's correlation coefficients and correlations. And that's all you have for your notes today. Make sure you get that done so that tomorrow on our Zoom call, if I ask any questions, you're not completely lost and you have these in your notes. Thanks, guys.